Okay, it's time for the dreaded problem solving. 7.4 is problem solving with two variables. They don't call it applications this time, they call it problem solving. Interesting. Okay, here's our steps. The first thing you're going to do is you're going to use two variables for these questions. Up until now in high school math, whenever we've had word problems and we've assigned an x to something or a y to something, and we've just used the one letter. But now, because we know how to solve systems of equations, we can use two letters. So you don't have to use x and y, although we often will. Then, because we have two unknowns, x and y, or a and b, or whatever, then you need to come up with two equations to make it a system of equations. Then you're going to use either elimination, which we also called addition or subtraction, or we're going to use substitution. So there's two different possibilities here, elimination or substitution, in order to solve the system of equations. Next thing, check your solution if you want to. Make sure you got the right answer. And the fifth thing, which is important, is you're going to make sure that you clearly answer the question that was asked. It's unfortunate when people do all the work and then forget to actually state what the answer is to the question that's being asked. Alright, let's try a couple. Louise purchased a flag whose length was 90 centimeters longer than its width. The perimeter of the flag was 540 centimeters. What are the dimensions of the flag? Alright, you could actually solve this one with only one variable, but it says that we're supposed to be answering these with two variables. So I like to always use x and y. Now you don't have to, you could definitely use like L and W for length and width, but because we always use x and y when we practice these questions, I like doing all the problems with x and y as well. So what are the two things we don't know in this question? Well, we don't know the dimensions. In other words, we don't know the length and we don't know the width. So I'm going to call x the length, and I'm going to call y the width. As I said, if you want, you could call L the length and W the width. Probably makes more sense, but I like x and y. Okay, so the first thing we see here is that the length was 90 centimeters longer than the width. So this is a little tricky. What a lot of people do here is they say, oh, the length was 90 centimeters longer, so 90 centimeters more. So you take the length, x, and since it's 90 more, it's plus 90. And if you were to do, and they say that equals width, equals y. If you were to do that, you'd be wrong. Why would that be? Because x is bigger, right? The length is bigger by 90. So in order to get the same as y, what do we actually have to do? We don't add 90 to get the same. We actually have to subtract 90 to get the same. Confusing, isn't it? Let me say it this way. If I was 20 years older than you, sadly, I'm more than 20 years older than you. So here's you. And you have your age. Think of your age in that circle right there. That's your age. Here's me, Mr. Wodge. And my age is in here. Okay? Now, if we wanted to get the same numbers, and I told you my age was 20 more, would I add 20 to yours to get the same, or would I add 20 to mine to get the same? I'd obviously add 20 to yours. If I add 20 to mine, I'll now be 40 years more, right? So that's why you would take the smaller one and add 20 to it. So, because it tells us here that the length is bigger, it means we have to subtract 90 from x. Or the other way you could do it is you could add 90 to the smaller one, and the smaller one is the width. Either one of these will work. Is there one you prefer? Well, I always like using the pluses and not the minuses, so we could go with the second one if you want. But either one of them will work. I'll go with this one. Alright, what's the other thing we know? We know the perimeter of the flag was 540 centimeters. Now, how do you get the perimeter? Think of a flag here. The perimeter is this side, plus this side, plus this side, plus this side. So if you think of it, it's two lengths added to two widths. It's length plus width, or two lengths plus two widths. So that's the way I'll write it. Two lengths, or 2x, plus two widths, or 2y, equals the whole perimeter, which is 540. Okay, here's our system of equations. We have to solve this system of equations. What would be the best way to solve this? Well, here's what I notice. I notice I have this x equals over here. Hey, I've already isolated x. So what would be an easy way to solve this? I would solve by substitution. Why? Because you don't have to solve by substitution, but I think it's the easiest because you already have isolated an x. And once you've isolated the x, you just have to plug that into wherever you see the x here. So that's what I'm going to do now. I'm going to rewrite this second equation. So let me number this. This is 1, this is 2. I'm going to rewrite this second equation, but where I see x, so 2x, I'm not going to write x. I'm going to write y plus 90, because that's how much x is equal to. Then plus 2y equals 540. Okay, now I solve that. How do I solve that? Well, the first thing I should do is do the mountains here. Distributive property. 2 times y is 2y. 2 times 90 is 180. And then I'd have plus 2y equals 540. Let's do two steps at once. 2y plus 2y on this side is 4y. And we also have to take 180 away from both sides. Take 180 away from here and 180 away from there. And if you do that, you'll be left with 360 on this side. Then we divide by 4 and divide by 4. That gets rid of those 4's. So you're left with y equals 90. Okay, good. So we now know that the width is 90, right? Since y is the width and we got that the y is 90, we know that the width is 90. But we still have to get the length. How do we do that? Well, we're going to have to substitute. Let's substitute into 1. You can do into either, but I'll do into 1. So x equals, I don't know what x equals, y, which is 90, plus another 90. So x equals 180. There you go, we got our answer. The length is 180. So have we done all the steps? Well, we used two variables. We came up with two equations. Yeah, there they are. We used elimination in this case. We still need to check our answer. Okay, well, let's do that. Let's check our answer. Check. So we're using these two equations up here. In the first one, we have x, which is 180, equals y, which is 90, plus 90. Is that true? 180? Yeah, that's true. Number 2. 2x, so that's 2 times 180, because x is 180. This is an x here, right? X is 180, plus 2 times y, and y is 90, equals 540. Is that true? 2 times 180 is 360. 2 times 90 is 180, equals 540, and if you do that, you'll find that's right too. So we have the answer right. Okay, the last step, don't forget this. I asked what are the dimensions of the flag. If you just left this huge mess here, this is great. I give you almost all the marks. But I'm not totally clear you have the right answer. So what I would do, I know you hate this, I hate it too, but you need to write a little sentence for me or something. So the length is 180 centimeters and the width is 90 centimeters. Now I'm totally clear you understand what the question is and you have the answer. Okay, just like that. Second one. On a visit to the museum, 1 adult and 3 children pay $27.75, while 2 adults and 2 children pay $27.50. What's the cost of each type of ticket? So what are the two things we don't know here on column X and Y? Well, what we're trying to find is the cost of each type of ticket. So let's let X equal the cost of an adult ticket. And let's let Y equal the cost of a child ticket. So in the first part of the question it says 1 adult and 3 children pay $27.75. So 1 adult, so that's one of the X's, or just X, you can put 1X if you want, or just X, plus 3 times the children. Well, if each children's one is Y and we have 3 children, it would be 3Y. And when you total it all up, that costs $27.75. Now, there's some more information here. 2 adult tickets, so that's 2 times X, 2 times the cost of an adult ticket, plus 2 children's tickets, so 2Y, 2 times the cost of a children's ticket, equals $27.50. There's our two questions, our two equations, I should say. Okay, our system of equations. We have to solve this. How do you want to solve this one? Well, again, remember this is just x here. It has a coefficient of 1 here. It's going to be really easy to isolate that x. So I think, again, I would solve by substitution. You don't need to. You could certainly solve by elimination. You could multiply everything in the top equation by 2, and then you could eliminate the 2x's and the 2x's. That's an easy way to do it too. But I'm going to do it by substitution. So for number 1, what I'm going to do is I'm going to isolate this x. So I'm going to leave the x there. You could put 1x, but why not just x? And then I have to move the 3y to the other side. So what I'm left with is 27.75, and the 3y moves over and becomes negative 3y. Okay, good. That's what I will now substitute into the second one. So it says 2 times x, but I know x. X is 27.75 minus 3y plus 2y equals 27.50, and then I solve. Mountains, you'll see it becomes very similar, most of them, doesn't it? 2 times 27.75, you might need to get a calculator out for that. It equals 55.50. Take away 2 times 3y is 6y, plus 2y equals 2750. Okay, next step, we can do two steps at once again, I think. Let's combine this. Negative 6y plus 2y is negative 4y. And at the same time, let's subtract 5550 from both sides. Again, you might need a calculator, but when you subtract 2750, take away 5550, you end up with negative 28. And the last thing we have to do is divide by negative 4 and divide by negative 4. These cancel, you're left with y equals 7. Great! Now we want to figure out what x is. So we're going to substitute into, which one do you want, 1 or 2? I'll substitute into 1. So I have 1x, or just x, plus 3y, and y is 7, equals 2775. So x plus 21 equals 2775. If you subtract 21 from both sides, you end up with the answer x equals 675. Great! If we'd like, we could check these answers. This will probably be the last one I'll check because it takes so much time. But anyway, we want to check these two here. So we have 1x, or 675, plus 3 times y, which is 7, equals 2775. So this is the first one we're checking. So that's 675 plus 3 times 7 is 21, equals 2775, and that's definitely true. And then for the second one, we have 2 times x is 675, 675, plus 2 y's, and y is 7, equals 2750. 2 times 675 is 1350. 2 times 7 is 14, and it's supposed to equal 2750, and it does. Hey, that's interesting what that says, isn't it? I'll check that out later. Okay, so now what's the last thing we have to do? We have to write a little sentence that says what the answer to the question is. So, what are the costs? The cost of an adult ticket is X, and X is 675. So, the cost of an adult ticket is 675. A child's ticket costs, $7. Kind of weird, isn't it? Adult ticket's less than a child ticket. Not very common, but I guess it could happen sometimes. Okay, that's 2 done. 2 to go. Alright, these are harder. Okay, if you can get these this type on the front here, you're in good shape. And then probably what I'll do on a test, I'll give you like maybe 2 questions like these ones, and you have to pick one of them and answer. So yeah, these are definitely a little bit harder. So this is a classic. This is where you have an amount, like for example in this question you have milk that has 3.25% milk fat. It's mixed with milk that has 1% milk fat, and you have to figure out a mixture, how much of each is needed to obtain 60 milliliters of milk that has 3% milk fat. So this is very common in these mixture questions where you have a certain percentage of acid or of milk or of, I don't know, gold or whatever, and then you mix them together and you have to get a certain different percentage. So they're all kind of answered the same way, so I'll call X and Y. What are the 2 things I don't know? Well, we want to know how much of each is needed. How much of what? What are we mixing together? Well, we're mixing milk together. What kind of milk? One type of milk is 3.25% milk fat, and the other one's 1% milk fat. So let's let X equal the amount of 3.25% milk, and Y equals, apparently I don't say the word milk properly, so if it's weirding you out, I'm sorry. I remember a whole class was once making fun of me for how I said milk. I'm trying to do better. I think I used to say milk, and now I'm trying to say milk, which almost sounds the same to me, but apparently I don't say it right. And Y is the amount of 1% milk. Now I'm so self-conscious every time I say the word milk. Alright, so what do we know? We know we want to have 60 milliliters of milk total. So if you take the amount of 3.25% milk and add the amount of 1% milk, you need to end up with 60. In other words, X plus Y needs to equal 60. Okay, that's the easy part. Here comes the harder part. Now we're going to, so this is just like the amounts right here. If we want, I could even write amount of liquid. Now we have to think of the milk fat in the second equation. So total, you want to have 60 milliliters, but 3% of it has to be milk fat. So 3% of 60. How do you get 3% of 60? You change 3% into a decimal, which is 0.03, and you multiply by 60. So on this side, that's the total amount of milk fat you should have. Now, where should the milk fat come from? Well, you should get some from X, right? You have this certain amount of milk, and what you want to do is you want to multiply that by 3.25%. So you change that to a decimal, 0.0325, and multiply that by X. And then for the Y, the 1% milk, well, 1% milk is 0.01, and that you multiply by Y. So this is the way your two equations are always going to look. The first one's just going to be the total amounts added together. The other one's going to have to do with like the percentage of acid or percentage of fat or percentage of gold or percent of whatever. And it's going to be very similar to this type here. Alright, how are we going to solve this? Well, we could very easily isolate one of these x's and y's, but since I haven't done it yet, I'm going to solve this by elimination. So remember, for elimination, I'll call this 1, call this 2. I want to get the x's either exactly the same or opposites, or I want to get the y's exactly the same or opposites. Okay, I'm going to get the y's exactly the same. How could I do that? Well, how about if I multiply everything in the first equation by 0.01? If I multiply 0.01 times 1, times y, sorry, I get 0.01y, which is exactly the same as what I have here. So that's what I'm going to do. I'm going to take this first equation, x plus y equals 60, but I'm going to multiply it by 0.01. I'm going to multiply all the terms in there by 0.01. So 0.01 times x is 0.01x. 0.01 times y is 0.01y. And 0.01 times 60 is 0.6. Grab a calculator if you're not sure about that. Okay, then I'm going to rewrite the second equation. So I have 0.0325x plus 0.01y equals, now look on this other side, we have 60 times 0.03. I might as well do that right now. So if you were to do that, multiply 60 times 0.03, you'll end up with 1.8. Great. Now we're ready to eliminate. So again, this is 0.01y, this is 0.01y. They're both positive. How am I going to eliminate? I'm going to add or am I going to subtract? I better subtract to get them to disappear. So let's do that. 0.01x take away 0.0325x equals, calculator time. 0.01 take away 0.0325 equals negative 0.0225. 0.01y take away 0.01y is nothing. You don't need to write that. And 0.6 take away 1.8 equals negative 1.2. You can use your calculator if you want. Okay, I forgot to put x here, didn't I? Did you notice that? I forgot to put the x when I subtracted those. Okay, last step is, since this is negative 0.0225 times x, I need to divide by negative 0.0225 and do the same over here, divide by negative 0.0225. So what happens? These cancel, and I'm left with x on this side. A negative divided by negative is positive, so I'm going to end up with a positive amount, which is good. It'd be weird if we didn't have a positive amount. And what I need to divide is 1.2 divided by 0.0225. And if I do that, I get 53.333333, 53 and a third. Let's just round to one decimal place. We'll call it 53.3. So our answer is x equals 53.3. Awesome. Now we need to substitute to get what y is. Look, here's an easy place to substitute, right in this equation right here. So we will substitute into 1. And what we get is x, which is 53.3. Whoops, I like using a different color here. 53.3 plus y equals 60. Last thing you have to do is subtract 53.3, subtract 53.3. You'll get y equals 6.7. Finished. Should we check it? Well, you can check it if you want. You can see the top equation definitely works. 53.3 plus 6.7 is definitely 60. The second one's a little bit more difficult, but you can certainly do it with a calculator. I invite you to go ahead and do that. I know these answers are correct. However, I still need to say exactly what my answer is. So what am I trying to answer here? I'm trying to answer what volume of each is needed to obtain 60 milliliters of milk. Okay, I found that I need 53.3 is the amount of 3.25% milk. 53.3 what? Well, if we look up here, we're talking about milliliters. So here comes the answer. We need 53.3 milliliters of, what's X again? 3.25% milk. 3.25% milk fat, I suppose, milk. And we need 6.7 milliliters of 1% milk fat, milk. Okay, you do need to say something like that on a test or a quiz, otherwise I'm not totally clear you understand what you've just found out. It's great you can find answers, it's also good if you understand what your answer means. So make sure you give me something like this. Okay, last one. Another classic is when you have things moving in different directions and they're going at different speed because of air currents or water currents and stuff like that. It is a total classic. So this is all based on the fact, these distance and speed questions are all based on the fact that the distance you move is equal to the speed you're traveling times the time that you're traveling at that speed. If I'm traveling at 2 kilometers an hour and I travel for 5 hours, how far did I go? 2 times 5 is 10, right? This is what this is all based on. So what you're going to do is you're going to actually make a little table. And you're going to put speed, you're going to put time, and you're going to put distance. This is always going to be the case with these questions where you have things moving or comparing their distances and stuff like that. And we're going to write in the table what we know about the speed and the time and the distance. And what are we talking about here? It says a boat travels 110 kilometers in 2 hours when it's moving with the current, but only 90 kilometers in 2 hours when it travels against the current. Find the speed of the boat in still water. In other words, if there was no current at all, how fast would the boat be going? Okay, so the two things we have here that we don't know, we have the speed of the boat, so let's call x the speed of the boat. And the other thing we don't know is the speed of the current. You know what a current is, right? That's like in water when you see it moving. That's the push of water is the current. Okay, so there's two types of motion. And the types of motion you always run right over here. So the types of motion we have here are with the current, the boat's going with current, and we have when the boat's going against the current. When does the boat go faster? When it's going with the current or against the current? With the current's faster, right? You're getting an extra push. So the speed, if we look at here at what the speed is when it's with the current, well, the speed of the boat is x, but then the current gives it an extra push. So actually the speed is x plus the push of the current, x plus y. How about when it goes against the current? Well, the speed of the boat's still x, right? It's still trying to go at the same speed, but now it's getting pushed against. It's being slowed down. How much is it getting slowed down? By the current. So it's x minus y. Good. The time. How long did it move? 2 hours one way and 2 hours the other way. 2, 2. The distance. How far did it travel with the current? It traveled 110 kilometers. How far did it travel against the current? Only 90 kilometers. Great. We're almost ready to go here. What we need to do now is realize that distance equals speed times time. This equation right here. So that's literally what we're going to do. We're going to write our two equations as distance, 110, equals speed, x plus y, times time. And the way I'll write that is like this. Right? If we want to multiply x plus y times 2, it's the same as 2 times x plus y. Okay, that's one of our equations. The other equation we have is distance, 90, equals speed, x minus y, times time, 2. And again, I'll just put it out front like that. Okay, there's actually a bunch of different ways you could solve this equation. I will do it a slightly longer way, but I think it's a way that more people will understand. And so what I'm going to do is I'm going to do mountains on both of these, just to simplify it a little bit. So 110 equals 2 times x is 2x, 2 times y is 2y. 90 equals 2 times x is 2x, 2 times negative y is negative 2y. Alright, let's solve. Hey, what would be an awesome way to solve this? No doubt about it. The best way to solve this is by elimination. And even with elimination, you have a choice. Since you have 2x and 2x, you could solve by subtracting. You go 2x minus 2x and you have no x's. But since you have 2y and negative 2y, you could also solve by adding. And then 2y plus negative 2y equals no y's, and you could get rid of the y's that way. I like to add more than I like subtracting, so I'm going to add, but you do it either way you want. When I add, I get 110 plus 90 over here, that equals 200. 2x plus 2x is 4x, and 2y plus negative 2y is nothing. That's gone. So I'm just left with this. Hey, I'm almost done. Divide by 4, x equals 50. Now I need to substitute to get one of the other, to get the y value. So you're going to substitute into one of these. Doesn't matter. Again, I like avoiding subtracting signs, so I'll substitute into 1. So I get 110 equals 2, x is 50, plus y. And again, I'll go and do this. I could have substituted into this one too, actually, but it doesn't matter. This is fine. So I get 110 equals 2 times 50 is 100, plus 2y. Subtract 100 from both sides, so you get 10 equals 2y. Divide by 2, you'll get y equals 5. Great. This one would be easier to check if you want. X plus y you do first in brackets. That's 5 plus 50 is 55. Multiply it by 2. 2 times 55 is 110. That worked. X minus y, that's 50 minus 5, which is 45. And then multiply that by 2. 2 times 45 is 90. That worked. So I definitely have the right answer. Last thing I need to do is answer the question. So what's the question? The question is, find the speed of the boat in still water. All you need to know is what the speed of the boat is. Well, the speed of the boat is x, so all you have to do is look what x is. Here it is right here. X is 50. So the speed of the boat is 50. 50 what? If you just put 50, that's not good enough. It's 50, what are we talking about here? Kilometers per hour. So it's 50 kilometers an hour. And we're done. What's this number, by the way? We didn't ask for it, but what is that? Well, that's whatever y is. Y is the speed of the current. So the speed of the current is 5 kilometers an hour. But I didn't ask for that, so you don't need to write it down. Okay, that's it. Word problems. 2, you really should master this type on the front, and 2 tougher ones. It'd be great if you could figure at least one of these 2 types out, because you'll have a choice on the test to do one of these type of questions or both for bonus. Good luck with it.